So we are now it's home stretch. You know, we have just one more hour of insightful and thoughtful discussions. And after that, we're going to have a good time at the Greg Club. So again, I'm very excited for this. I must say, I am tired, but at the same time, you know, this excitement keeps me going, and I'm happy to be here. So for the second part of the first part of the panel, we really learned what a healthy planet should look like, right? We learned of whether we should be calling our current geological epoch Anthropocene or not. And we really also covered what is happening with our global biodiversity. And now I would like us to move a little bit more to the social aspect of climate change and our climate crisis, meaning what really is the source of this problem. As Dr. Moser has touched upon already, we need to decrease our carbon emissions. There's no doubt about it. But where are those carbon emissions coming from? And I must say, a lot of again, I'm not a climate scientist, but this is a topic in which I'm very interested in. And a lot of the things I learn about come from YouTube. And, you know, of course, I try to find reliable YouTube channels. And the Vice News channel really is insightful. And I have here, so it's a 18-minute long video, but we're going to just watch 1 minute and 48 seconds, okay? And I found this video very compelling, and I want to share with you. So let's take a look.
May I just say to all delegates, I apologize for the way this process has unfolded. I'm deeply sorry.
This is the president of COP26, welling up with tears as he closes negotiations on our last potential chance to avert climate catastrophe. COP26 has been a failure. Why did it fail? Because of people like this. A highly paid network of politicians, lobbyists, and investors conspiring from the shadows to block climate action, sacrificing humanity itself for short-term profit. These people are the biggest threat to our planet right now, and they're winning. Mr. Pink knows how they greenwash your money. Mr. White knows how they buy your politicians. Miss Blue knows how they steal your elections. And Miss Black knows how they sue the shit out of your government. They've agreed to reveal to us how these dark arts work.
This green marketing is intended to trick all of us. They put them up in a 5-star hotel. There's maybe an expensive handbag with caviar. I became a victim of harassment because I used the word British Hughes.
The public doesn't have as much access to this information because the scale of power of fossil companies exists in every part of your life.
So my message here with this second part of the panel really is about where these carbon emissions are coming from. And I wanted to start, and you know, it's hard not to vilify certain industries, specifically the oil industry. Did it get to work there? What do you think? Well, it's okay. Let's just, when you remove, we jump that slide. Let's not present the video, that's fine. Well, this past year, certain oil industries have reported record highest profits to date since they were, thank you, Stephanie. They have, here, wait, I lost my notes for a second, I apologize. Here. These are called the 5 big oil winners. Within the span of 1 year, the 5 big oil companies, ExxonMobil, Chevron, Shell, BP, and Total Energies, more than doubled their profits. And here I'm showing you some of those numbers. Securing a total profit of 59.2 billion American dollars, U.S. oil giant ExxonMobil recorded the highest total of the lot. In 2021, the company's profits were 23 billion, or less than half of 2022's haul. The company ExxonMobil was joined by Chevron, whose profit rose by over 134% to 36.5 billion. And Shell, whose profit of $39.9 billion was the highest in the company's 115-year history. So this is just like the graph behind me shows a little bit of that. Some of those numbers. And not surprisingly, The Guardian came up with a series of articles, investigative articles, that really revealed what they call the carbon bombs. And this really was a compilation of those articles in which they titled, Revealed, the carbon bombs set to trigger catastrophic climate breakdown. And I'm gonna read to you from this compilation of articles what the carbon bombs are. The fossil fuel industry's short-term expansion plans involve the start of oil and gas projects that will produce greenhouse gases equivalent to a decade of CO2 emissions from China, the world's biggest polluter. So let's just think about this. Carbon bombs altogether, when they are ignited, when those oil-producing projects start, they will release enough carbon, which is equivalent to a decade of CO2 emissions from China, which currently is the world's biggest polluter. These plans include 195 carbon bombs, gigantic oil and gas projects that would each result in at least 1 billion tons of CO2 emissions over their lifetimes, in total equivalent to about 18 years of current global CO2 emissions. About 60% of these have already started pumping carbon out. So here we can see, again, this is just the graphic representation of what I told you. So our current carbon budget, if we want to stay below the Paris Climate Agreement goal of temperature increase of 1.5 degrees Celsius, our carbon budget, our planetary carbon budget would be of 500 gigatons, right? In 2019 alone, our global emissions were of 37 gigatons. However, if all those carbon bombs, which were those 195 oil-producing projects, if all of them are ignited, we will be releasing 646 gigatons of CO2. In other words, our plans to keep the temperature increase below 1.5 degrees Celsius will go out the window. And as if this weren't enough, we have the biggest oil-producing companies investing a lot of money in different sectors, including marketing. And here I'm showing you how much those companies are planning to invest in their marketing activities and production activities as well per day until 2030. So as Hugh mentioned earlier today, a few decades ago, we were thinking about, let's estimate, let's draw estimates to 2050. And the clock is ticking, and those companies, those oil companies, which have been pumping carbon to our atmosphere for decades now, they're still planning to carry on spending billions of dollars per day in advertisement and oil production. So the problem is, also as Dr. Katrina has said, we need to do something about it, and we aren't doing anything. To the contrary, the data shows us that things are gonna get worse in terms of carbon emissions. Really, those big oil-producing companies they have those carbon bombs ready to be ignited. And my question to the panel is, should biologists engage more with policymakers? Because biologists can study biodiversity as much as they want. We can also study or help engineers to develop techniques that could save us, such as carbon capture and storage. But according to my humble opinion, it really boils down to how much we can inform policy decisions and how much we can then curtail our current carbon emissions. So my question is, should biologists engage more? And if so, how can they do that?
Yes, biologists should engage more in policymaking. So should everybody. I think this is not a time to sit aside. You got to get involved. You got to take action. You've got to write letters. And it doesn't take everybody to be engaged. There's like social tipping points too. We talked earlier about tipping points. around physical science, ice, glacier ice and things like that, but there are social tipping points. We just have to get enough people engaged and focused on mitigation. I'm going to beat that one to death, but that is what we have to do, is reduce fossil fuel emissions. That's our only way out of this. There's no quick fix, and any quick fixes you hear about, they're not going to deal with the other issues that are part of climate change. For example, ocean acidification. So we really have to reduce fossil fuel emissions. You, Mateus, you raised the issues of oil industries. Yes, they are responsible for a large part of the problem, and they hid scientific findings. They knew in the 60s, they knew that increasing carbon dioxide in the atmosphere would lead to warming, and that was suppressed. So they are responsible, but it doesn't help us move forward. What we need to do is stop subsidizing them. We governments subsidize fossil fuel companies. Canada, we need to cut out fossil fuel emissions. We don't need to develop any new, I'll call them carbon bombs. We just, there's lots of things we can do here at Western. Divestment would be one step forward, right? Reducing emissions. If a university can't reduce their carbon emissions, how do we expect anyone else to do it, right? So I think all of these things are ways as academics that we can take a step forward. And I think we're privileged to be here. We're privileged to have this education, but that comes with it comes a responsibility to take action and help make a better climate future for our children and grandchildren. So.
Yeah, thank you very much. So I also think scientists should work closely with policymakers. I think most of the graduate students know, like, if you have subscribed to different scientific journals, there is always every day papers coming out, like, with new knowledge about the impact of climate change, impact of elevated CO2 on biological organisms. But when you try to look at the policies that are actually regulating our ecosystems, are lagging way behind. And then you wonder, like, why is there this disconnect between science and policies? Because there are less, scientists willing to be involved with policy makers, because that's how changes are actually going to happen. And also, the people making policies don't really have this scientific knowledge about the actual impact of increasing of CO2. And I think it's our duty to actually proactively engage with them and give them knowledge. And over time, I think they get to understand actually the importance of the policies they are making. Maybe just in one example I can give, there is one project I'm involved in Rwanda, in Africa, where we want to promote a reforestation program using native species instead of like eucalyptus, which are exotic in those places. And in this project, we actually host workshop every year to be able to talk to policymakers, to show them the findings from our project, and also get the inputs of what they actually want or where they have some knowledge gaps that they need to address. And I think so far it's working. It's promising. The collaboration between them is promising. And I think as scientists we should be thinking about doing science, but also being able to translate this knowledge to policymakers who get to do the actual decision that affect our society.
No? Now I'm back. Wonderful. Thank you very much, the panel, for your insights. So moving actually to our very last topic, which I would like to take to take our time and spend some time here discussing those concepts. As I said, I think it is important for us really to dissect our current situation, be realistic, right? But also, it is also important for us to stay hopeful and discuss what are the future steps for humanity really to survive, right? So we know we are in trouble. We know we need to cut down on our carbon emissions, but what else can we do? What are the next steps? So this would fall under carbon removal and promising technologies. And what I'm showing you here really is just a small sample of countries that have committed to net zero. Most of these countries have committed to achieve net zero or net carbon emissions zero by 2050. Some of those countries have committed to 2060. Some of them have committed to a little earlier, to 1245. But most of them have 1250 as their landmark. And what is interesting here, and those two groups of countries are highlighted in this image, is that we have countries that have historically, they are the main contributors of the carbon emissions. So those are high-income countries, or if you will, developed countries, as we can see here. But we also have countries that they have not historically contributed to the current carbon concentration in the atmosphere. So we have Belize, Micronesia, Marshall Islands, and even those countries have already committed to net zero because they know of the importance of this commitment. As we were discussing earlier today about planetary boundaries and tipping points and core tipping points, this is a planetary problem that demands a planetary solution. So it's nice to see all countries coming together. What I also wanted to say is that so these promises are being made not only in the governmental sphere, but also in the private sector, which arguably it really is necessary and perhaps the most important sector to buy into this fight. So, you know, and this is a recent, how would I say, collective action, if you will. Here I'm showing you the private sector commitment to carbon dioxide removal technologies. So CDR stands for Carbon Dioxide Removal Technologies. And as you can see, since 2020, we have larger corporations like Microsoft and Shopify that they are investing a lot of money in those technologies. But the problem is, if we take a look at those figures, is that to reach, and we're talking here about, well, those are estimates. So to reach net zero by 2050, we would have to have a permanent carbon dioxide reduction of 3.8 billion tons per year. So we need to have those technologies. So it's not just about decreasing the amount of carbon emissions, it is also removing the carbon that is in the atmosphere. Because let's remember, the current carbon concentration in the atmosphere is not a product of yesterday's emission. It's a product of the emissions that have been happening for decades now. So if we want to reach the Paris Climate Agreement, for instance, a goal of 1.5 temperature increase, we also need to remove a lot of the carbon dioxide that is in the atmosphere. So the estimates are that we need to, by 2050, we need to be removing permanently around 3.8 billion tons of CO2 in the atmosphere per year. Oh, sorry, I skipped. I did not want to skip the, I thought I had moved to the slide, sorry. So this pink here shows us the US estimates or promises to capture carbon dioxide. So as of now, the US has committed to permanently remove 500 million tons of CO2 per year. And let's remember, globally saying we need to remove 3.8 billion tons. So the US has already committed 500 million tons per year. But the problem is this very tiny bar that we can barely see from afar, showing how much our current technology can remove of CO2 from our atmosphere per year. We're talking about only 2 million tons per year. So even though 2 million tons sounds like a lot, because it is a lot, we still need, so this is where our current technology is, but we still need to reach this level. And of course, we cannot help but feel overwhelmed by these numbers, right? And that's why I brought experts to talk to us today. So I'm telling you, we need to remove all this CO2 from the atmosphere, and it's overwhelming because our technologies aren't just ready for it. And at the same time, as if this weren't enough, I'm also showing you here, as we have discussed already, the increase in CO2 emissions throughout the world. So in the world as well, but if we break down in regions, we can see how the development of medium income and low income countries is contributing to the CO2 emissions worldwide. So there is also an aspect that I hope Dr. Katrina will touch upon on the social aspect of it. How do we account for the fact that most countries in the world really haven't contributed significantly to the current CO2 concentration in our atmosphere, right? So we have, if you will, a small group of developed countries that have historically emitted the greatest amounts of CO2 in the world. And now these countries, rightly so, I would say, are asking everyone else to reduce their emissions and hopefully even remove the CO2 from the atmosphere. Now, an interesting point is that, so I want to finish on a hopeful note, if you will, is that other technologies, such as, here I'm showing you the solar photovoltaic modules, the price of solar photovoltaic modules has decreased significantly. So for the longest time, the adoption of renewable energy sources has always been lagging behind because it was very expensive. But very recently, in fact, I would say 10 years ago or so, perhaps even less than that, certain renewable energy sources have become quite cheap. And those would be solar energy and wind energy. And right now, actually, they are economically saying they are competitive. So it is cheaper depending on the year, depending on the moment of the month and the country. It is cheaper to produce solar or wind energy than using oil. So this is promising, right? If a few decades ago we were talking about very expensive alternative technologies that we couldn't adopt, now we can adopt those. And that really, makes us think perhaps we can develop cheap and effective carbon storage and removal technologies. So my question for the panel, and this would be the ending question, if you will, really is, what are the promising technologies for a future net zero? Because another thing I want to say is that, this is a 2-hour panel. We don't have time to cover everything. But note that I have not touched upon geoengineering, which is very controversial, and perhaps the panel can touch upon geoengineering and other promising technologies. And I would like to hear from the panel. So what are those technologies? And perhaps even, what is net zero? Is it achievable at all? And again, to think about our audience here today, where can biologists contribute? Yeah.
Yeah. So it's sort of it is outside my expertise to comment in great deal on the technologies, but I think thinking back as how a biologist might approach this problem, CO2, it's a waste product problem essentially. But my concern for any technology is resources, because that's at the flip side of, or the other aspect of growth and so on, and population is resource use. So I think any successful technology right from the start has to be something where you're not causing a resource crunch. You think of battery technology and what components that go into that and so on. So I know I've heard some really interesting discussion around the growth and collapse of Pacific Island societies historically. And what was a little bit ominous about a lesson learned from a lot of those examples was, in many cases, technology only served to delay and intensify problems because it would put a crunch onto resources, right? So I think the key is to think ahead and say, okay, well, we can't rely on a technology that, because I think the fallacy is to say we'll have a future technology that'll overcome the future problem as well. But when it comes to certain types of resources that aren't renewable, that it not only becomes a problem in terms of running out of them, but it creates a lot of interesting geopolitical problems. Phosphorus would be a good example. There's concerns in the next few centuries of running out of mineable phosphorus. And I think most of the mineable phosphorus is in Morocco. So what happens when one country or a small group of countries ends up with that resource as well? It causes a lot of trouble. So I don't have I guess the expertise to comment on the best technologies, but I think we need to think up the best approach to long-term sustainability of those technologies.
Yeah, one thing I can comment on that is just to maybe go back to the basics and try to simply reverse like deforestation, because I study, my research covers photosynthesis, leaf respiration, and the carbon fluxes in terrestrial forests. But I think if we stop deforestation and also increase the forest cover, I think that can be simple. It sounds simple, but I think it's possible to reverse the carbon emissions and try to, over time, reduce carbon or increase carbon sequestration in terrestrial ecosystems. Of course, sometimes deforestation happens because the population is increasing, perhaps coming up with better urbanization strategies that do not require a lot of space can also be combined with, reforestation, increasing the forest cover.
Yeah, I totally agree with you, Eric. I think it is a simple but effective solution is reforestation and afforestation. And I think of a talk I heard by Robin Wall-Kimmerer, who really focused on plants and algae as being a really simple but beautiful way to reduce carbon in the atmosphere. And if you haven't read her book, Braiding Sweetgrass, all biologists should read that book. It's incredible, and it will change your thinking about some of these issues. I want to pick up on one more thing. Again, I'm not really in a position to say what are the best technologies available to us, but I think you're dead on that they're only going to get us so far. And again, I mentioned at the very beginning of the panel, we really have to rethink everything, and we need to make a paradigm shift. And I think bringing more voices to the table when we're talking about these issues will really help facilitate a paradigm shift where we aren't so focused on growth and we're not so focused on what we want, but just what we need. And I think, again, I teach climate change, and I've had students come to me and say, I am so depressed after taking your course. And that's not how you should leave today. Because I've been studying climate change for 30 years, and it is depressing, and I've seen little happen. But I remain optimistic and hopeful, because I think I see when I teach my class every year more and more young people coming and saying, yeah, we want to change, and we are willing to make big societal changes to tackle this problem. And that's what gives me hope. So don't leave depressed. Leave in a positive way and be ready to contribute. In your research, in your teaching, education is so important. And outside of academia, become involved in local politics and help make changes. So that's my advice for moving forward.
So what I'm hearing is that, again, as I said earlier today, biologists have a lot of work to do. And I agree, I could not, agree more with all what you have said, specifically about not feeling depressed. I think we have reached a moment in which, sure, we should acknowledge that it is overwhelming to look at this information, and we must be realistic. But we have just one choice, which is carry on, I want to say, fighting or trying to fix this problem, right? Because the other alternative, which is not doing anything, really it would cast our, extinction, I would say, the extinction of our species and the extinction of several other species that, those who have survived until now, I would say. But before I move to the closing remarks, I would like to open the floor for at least one or two questions from the audience, because I think it's always nice to have an interactive panel. So we have one question there. Perhaps, Stephanie, would you mind bringing the mic to the audience? Thank you.
Cool. Can you, yeah, okay, working. I have a specific question about Canada and mining, because right now there's increasing demand for minerals for things like electric vehicle batteries. And we have rich resources when it comes to that, but those areas also happen to coincide with boreal forests and particularly peatlands, which are, as we know, like huge carbon sinks, but also hold a lot of biodiversity. So there's this huge trade-off. And my inclination is not to mine it. But then if we are needing to meet our, or like, you know, decrease our emissions, and we're encouraging people to, you know, buy electric vehicles and stuff, I just wonder what your thoughts are on the panel about how we balance that trade-off between like extractive mining so that we can have our electric vehicles versus preserving biodiversity as well as carbon sinks that are so like important here in Canada.
Slowly.
Yeah, I guess what your question, I guess, gets me thinking about is, you know, sadly, I guess, or maybe it's just the reality of how things work, is even a lot of green initiatives are driven by people wanting to profit. So I guess if there's any way, you know, if it's going to come down to what you said, you know, weighing one thing against another in terms of a trade-off, as long as that is done in the proper context, as opposed to just having it profit-driven. So I don't know quite how to do that, but as long as people are making that rational comparison and not saying, well, here's how we can make the most money. But I think, unfortunately, the way things tend to get done is in terms of people trying to seek profit. So, you know, I guess that's where government's supposed to step in, but, yeah.
Go ahead.
Is that all we can say?
Well, it's such a hard question. And I don't have an answer for you. I do think, I guess I'll follow up a bit from what Hugh was saying. I think you want to have the right people at the table making those decisions on how do you move forward on that. Again, I also think we have to be careful. Like, we can't, you know, green energies are important. There's no question about it, right? And electric cars are important, and they need batteries, and they need certain minerals, right? And so how do we balance those two things? And again, I think having lots of voices at the table and talking about how you do that, we also have to keep reducing. We can't kind of keep living the way we do. Doesn't mean we can't have a good life, but we do need to reduce how much we consume in a place like Canada or North America or Europe. I'm really rambling now, but it is it's a really hard question.
Carbon sinks, but also the communities that live in those areas. Yeah. And so I think that's what you brought up in terms of communities. Sorry, I don't even mean to take all the time, but I was just saying that it's not just a trade-off between like mining and a carbon sink, but there are people who live in these areas and have lived in those areas sometimes for thousands of years and rely on the land and have really strong connections to the land, and they also obviously need to be part of the conversation, but I think those voices have very often been overlooked. And so I think I just wanted to point out that I neglected to include that, but that is just as important, if not more important, than those other trade-offs. But you're all nodding, so I assume that you just agree on.
And this is the purpose of this panel, right? We are not here to come up with solutions for these problems, because those problems are complex and we cannot come up with solutions with this panel. But really the idea is for us to, you know, start thinking about it, right? And again, before I go to my closing remarks, and I thank the panelists, is there any other question in the audience? Oh, we have a few. Wonderful. Oh my God. We're in for a good ride. Yeah, I mean, I would say let's take a few more questions. Yeah, okay. Omar over there. Yeah. Because it's not, we do not always have climate scientists before us to ask questions. So let's take advantage of the time.
Hello. Okay. Hi. So my question is concerning the natural carbon sinks that we have and are, currently killing. But with trees, as far as I understand, it's the deforestation that's the issue. So in theory, if we planted more trees, we would have more carbon sinks in that space. But our largest carbon sink is the ocean, and specifically organisms that capture carbon like phytoplankton. And as for them, they are dying because of ocean acidification and rising temperatures. So is there hope that another sort of aquatic species could fill this niche if it gets too bad, or could they adapt on a timescale that is relevant to what we're seeing in the changes in our climate?
I don't have a direct answer to that. I can simply speculate some of the. So one thing when we talk about increasing the tree cover, that idea is also controversial because. So, for example, in the COP 26, they mentioned that, for example, you may cut down a grassland, which store more carbon than simply putting a tree cover. So trees are not always the ultimate solution to increase carbon sequestration potential of an ecosystem. I guess as a biologist, we then need to actually understand, to know the actual estimate of the carbon sequestration potential of an ecosystem before we actually try to change it. For the ocean, I agree that the ocean stores a huge amount of carbon, and it's being threatened by ocean acidification. And I guess, one way to reverse that is to simply, as Katrina said, to reduce the CO2 emitted to the atmosphere, because that's the main problem to the ecosystem. So that's the only thing I can comment on.
Okay, so as biologists, I think we're in a very interesting spot in terms of where we're in society and how kind of everything has played out, we're in this place that we are trying to educate ourselves and also contribute to the scientific community in the papers that we're publishing, the knowledge that we have, et cetera, but also at the same time, we are members of society and we have this inherent responsibility to also try and make ourselves live a net zero lifestyle, or try to advocate. And of course, that's like inherent, it's incorporated into everything. But I think something I've struggled with personally, and maybe other people in this room can relate, is kind of trying to find that balance between educating myself on the issues and trying to broaden my scientific knowledge and also taking action, because I feel like we are at this point where we're spending time that we don't have time to spend. And I think something that was said earlier was that we're discovering species, or species are going extinct before we're discovering them. And that's valuable time that we're spending other places. So I was just wondering if you could each comment on kind of trying to find that balance and what maybe we can do as biologists.
Yeah, no, good question. I think one interesting aspect that you can consider is comes down to how we practice our science. Now, I've seen some interesting initiatives recently that we haven't gotten too far on, and with respect to even reducing what we use in terms of lab consumables and so on. So I guess we often don't think about it in that case. I remember being on a CO2 experiment where we were emitting CO2 into the atmosphere for the experiment, thinking, how much are we doing here? It wasn't that much. But what I think is kind of, I guess, an interesting opportunity going forward in terms of making our science more efficient. A lot of what we do now is kind of lab level based and sort of uncoordinated. People come up with an idea, a student runs off the project, and it's interesting when you write a synthesis, let's say about climate change or global change, you have this huge mix of information. You say, well, let's say we're looking at the effect of warming on a plant community. You say, well, it had a positive effect on productivity in this study, a negative effect in this study, and a neutral effect here. And you go back to those studies and you realize they've done them in very different ways. So I think moving forward, it would be interesting to thinking of ways of coordinating our science more across, there are efforts now. There's these coordinated distributed experiments, like there's DroughtNet, where they have 200 different sites across the world, and they say, okay, we're going to all do it the same way. So it's more efficient to organize the science better. I don't know if you've heard of the NEON in the United States, the National Ecological Observatory Network. That's a great plan as well, but it's only in the United States, right? It's not done more globally, and that also focuses on the fact that we tend to concentrate our research areas in certain areas and neglect others. So I don't know. I think one of the great opportunities for all of you moving forward is, we don't have many equivalents of like the James Webb Telescope for ecology. So if any of you want to be really visionary, think of how to like do something really big and meaningful that will channel our efforts more effectively.
To me, what I can add to that is everyone to get involved, because as I said earlier, we are producing a lot of data from science, but this data is having less impact because there is no one out there to translate these to policies. So I think there is an opportunity for researchers and also students, for example, to be involved in committees. For example, I'm serving on the committee, the Ecological Impact Committee in the City of London. And that's a place where everyone can actually, students or senior researchers can contribute. So that's one way to actually make changes happen faster, I think.
Yeah, I'll just add one little point. I think too, if you think long term, like I know it feels urgent, right now, but if you think over your life, there'll be times that you're more focused on your research, and then there'll be times, like for me, I would say, put more focus right now on education and advocacy around climate change. But I'm at a stage in my career that I can make that choice. Whereas when you're first starting out, it's maybe not so easy to make that choice. There is, as Eric said, there's lots of places you could contribute meaningfully without taking a huge amount of your time. But it is, I think if you take the long view, that there'll be opportunities along the way where you'll put more focus on one or the other and not kind of worry too much about it. It just kind of happens. But I think there are small things that everybody can help with. Yeah.
Hi. My question is kind of touching on what Hugh said earlier about like social tipping points and human behavior. So just given the increasing effects of climate change on society as a whole and the lack of action from companies and governments, will we reach a breaking point where we might see rioting? And would that need to actually happen to have change occur?
Wow, these are really good questions. I don't know the answer to that. Not a social scientist. I hope not. I hope not. Many great changes have occurred through peaceful protests, right? And that's what I hope happens now. But yeah, it's a really good question. All these questions are really good, making me think. So I don't know if either of you want to.
Well, what I always kind of find funny about ecology is, I guess we're kind of like economists. We're really bad at like predicting the future, but we're good at explaining what already happened, kind of, right? And so yeah, that's you picture all these different directions, these different scenarios, and yeah. So much like Katrina, I don't have an answer to the question, but in terms of thinking of ecology as a predictive science, I think Katrina had mentioned that in 30 years we really haven't come very far, and maybe with another 100 years we couldn't come much further because ecological systems have that inherent complexity, but it doesn't mean we can't, through that sort of sensitivity type analysis, come up with the idea of what are the best cautionary, what's the best cautionary information we can give in terms of how we know ecological systems work. So we can't say what's going to happen, but we can say what you should be most careful of. And that doesn't answer your question at all, but it just basically says, how it's hard to predict the future. And so, yeah. Anything, Eric, for that? No.
Wonderful.
Weird place to end.
No, I have a few closing remarks. Well, I must say, to begin with, I think so the panel was a personal project. So OE3C historically has had always at least 3 keynote speakers, and each keynote would speak to one of the 3 E's. And we had that during the conference this year. 3 wonderful keynote speakers, which really showed us what is it at the forefront of biology in their fields. But I must say, when we organized the conference, just like I stated in the opening remarks, we were wondering what would be the unifying theme that would bring together ecology, ethology, and evolution. And historically saying, evolution has always been seen as the unifying thread, right? Because, all living things evolve, they're all connected, they all share a common ancestor. But as I was speaking with Dr. Katrina before the panel, biology studies life. And right now, the biggest threat to life is our current climate crisis, the climate crisis and the related crisis as well. So my personal project was to bring the panel because if we don't discuss the climate crisis, if we don't come up with solutions, there won't be life, and then there won't be biology. And I think biologists, right? It's simply put, having these discussions, we are discussing the future of our careers and the future of humanity and the future of the planet. So I must say, I'm very happy that I had the chance to make this happen with the committee and everyone else and the volunteers, and I'm very happy to have everyone here. And I agree with the panel. I think we shouldn't end with a depressing note. We should be realistic, and this realism should ignite changes, both at the individual level, but also at the systemic level. And I do hope that we're going to walk away from this panel feeling sure, perhaps a little depressed, but also energized, and really trying to take action, whatever action we can take. For instance, this conference has avoided meat. My personal project really was to have a fully plant-based conference, which I could not achieve because of prices. Believe it or not, vegetarian food is cheaper than vegan food, even though vegetarian food has more food items, more ingredients than vegan food. But still, so the conference has been, I want to say 95% of it was plant-based. We had very few meals that had cheese or dairy in it. So that was a small step, right? That was already built in the design of the conference from the very beginning. So I do hope that the conference as a whole has not only informed you about your own disciplines, has not only allowed you to network with your peers and establish collaborations, but I also hope that the conference has given you food for thought on what ways you can take, what measures you can take moving forward. And I would like to thank the panelists. And as I said, you are all invited to join us in our award ceremony, which should start in a few minutes. And again, I would like to thank everyone here for being with us this year, for creating a safe environment for everyone, being kind to one another, being thoughtful, being open to new ideas. And yes, I could not be more happy. Thank you very much, everyone.